Hello everyone, my name is Tawfiq from Tenet Technetronics. I'll be giving you a brief introduction on the components that we have. Hello everyone, today I'll be giving you an introduction to a servo motor. As you can see, this is a servo motor. At times we require special types of applications for electrical motor where rotation of the motor is required for just a certain angle, not continuously for a long period of time as a DC motor rotates. For these applications, some special types of motors are required with some special arrangements which make the motor to rotate at a certain angle for a given electrical input signal. So for this we use a servo motor. This is normally a DC motor which is controlled by a specific angular rotation with the help of additional servo mechanism, that is a typical closed loop feedback control system. It has a rotary actuator that allows for precise control of angular motion, velocity and acceleration with great precision. So they are small in size, I can see here, but pack a big punch and are very energy efficient. The main reason why you use a servo motor instead of a DC motor is that it will only rotate as much as we want and then stop and wait for the next signal to take further action. This is unlike a DC motor which starts rotating as when the power is applied to it and the rotation continues until we switch off the power. We cannot control the rotation progress of an electrical motor, but we can only control the speed of the rotation, that is, it can be just turned on and turned off. This servo motor works on a servo mechanism, a mechanism called a servomechanism, sometimes also called a servo, which has three important components like a control device, an output sensor and a feedback system. So we'll just see what is the servomechanism is all about. So there is an automatic closed loop control system. Instead of controlling a device by applying variable input signal, it can be controlled by a feedback signal generated by comparing the output signal and a reference input signal, as we have seen in many applications. So when the reference input signal or command signal is applied to the system, it is compared with the output reference signal of the system produced by the output sensor, and with this we generate a third signal produced by the feedback system. So this third signal acts as the input of the control device. This input signal to the device presents as long as there is a logical difference between the reference signal and the output signal of the system. So once the desired output is achieved, there will be no longer differences between the reference input and the reference output. So hence the primary task of servomechanism is to maintain a stable output of desired value in the presence of disturbances. This servomechanism can usually only turn up to 90 degrees in either directions for a total of 180-degree movement. The motor's neutral position is defined as the position where the servo motor has the same amount of potential rotation in the both clockwise and counterclockwise direction. So this has a very great control. So when the servo motor is commanded to move, they move to a position and hold in that position. If an external force pushes that against the servo while the servo is holding a position, this servo will resist from moving out of that position. So that is called a torque rating. The maximum amount of force the servo can exert is called the torque rating of the servo. The servo will not hold their position forever though. So the position pulse must be repeated to instruct the servo to stay in the position. It has a number of applications. As we have seen, servo has been used for many applications, from toys to home electronics to cars and aeroplanes. If you have a radio control model car, aeroplane, helicopter, you can use at least a few servos in that. Servos also appear behind the scenes in devices we use every day. For electronic devices like DVD, Blu-ray, disc players are used to extend or retract the disc trays. Thank you for watching this video. Now let us see a demonstration for the servo motor, as I explained before. So I just connected an Arduino, and here you can see these pins. So one of the pins have been connected to the 9th pin of this Arduino, and one of the pin has been given to power supply, that is a 5-volt supply, as you can see here, and the other is given to the ground. So we'll just see here, the servo motor just rotates to 180 degree, that is 90 degree, 90 degree, and it just reverses back to the same position. So the coding has been already written in this Arduino, and it just start working once I get the power supply. So here we can see this rotating. So it rotates 180 degree, then comes back. Again 180 degree, comes back. So this is the working of a servo motor. Thank you for watching this video. If you have any doubts or queries, you can log on to www.tenettech.com or you can drop a mail to info@tenettech.com.